Hello viewers. So we are here with the next module on the chi-square test. In our previous module, we discussed about the introduction to the chi-square test. So here we are in this module going to talk about the first type of chi-square test conducted. This is called as the goodness of fit. So let's have a quick recap of what chi-square test is. A chi-square test is a statistical method which is used to determine the association between two categorical variables, right. So please remember this word categorical variable in context of chi-square is very important. It is used to test the hypothesis that is there a significant difference between the observed values and the expected values for a particular sample. So as we know that there are two types of chi-square test. First one is the chi-square test for the goodness of fit, and the second one is the chi-square test for the independence. So in this module we are going to only concentrate on the goodness of fit test, right. Now let's have a quick recap of the chi-square formula that we discussed in the previous module. The chi-square formula is as follows: chi-square is equal to summation of the observed values minus the expected values, square it up, divided by the expected value. Right. Now the problem is that how to put this formula into practice, right. So here we are to tell you that how to use the goodness of fit test for testing of hypothesis with the help of chi-square. Now what does this particular test claims? This particular test claims about the population proportions. So our null hypothesis for a chi-square test is always that the proportions of the observed values and the expected values is equal. That means there is no difference. And the alternative would be that the proportions are different for the observed values and the expected values. Now first thing we need to understand here is that first one, it is categorical variables are important. Second thing is that it is only conducted on data which is nominal or ordinal data, right. So when you talk about the scales of measurement, there are 4 types of scales of measurement, but then the categorical variables that you are using for a chi-square test, they should be having the nominal scale or the ordinal scale. Now let's take a numerical example and test the hypothesis with the help of the chi-square goodness of fit test. Okay. So the example goes as, in the 2000 Indian census, the ages of individuals in a small town were found to be as follows. So we have 3 categories here. First is less than 18, second is 18 to 35, and the next one is greater than 35 years of age. So in 2000 census, that means this is a data with the difference of 10 years. 2000 census says 20% of the population is in the category of less than 18 years of age, 30% are between 18 to 35 years, and 50% are greater than 35. Now next is that in 2010 the Indian census says the age of population here is taken as n is equal to 500. In 2010 the Indian census says that the ages of individuals, now here we have a sample of n is equal to 500. So the ages of individuals were sampled and found to be as follows. So here we have the numbers and not the percentages. So less than 18 years it is 121, 18 to 35 it is 288, and greater than 35 it is 91. The first thing that we need to decide for a hypothesis testing is the level of significance. This is also known as the level of significance, right. Now what does the level of significance means? The level of significance here we have used alpha is equal to 0.05. That means if I am conducting this particular, or if I am collecting this particular sample 100 times, it is quite a possibility that 95% of the times it is going to be the same. Okay. So there is only a 5% possibility or a probability that it would not be same. So in the formula there were 2 things. First one, observed values, and second is the expected values. Observed values would be what you have observed with the help of data collection methods. So here the observed values are 121 for less than 18 years category, 288 for 18 to 35 years category, and the category greater than 35 has 91, right. So our expected value would be based on the previous proportions, right. Now how do we calculate that? 20% of 500 would give you the expected value for less than 18 years. 30%, this 30 comes from here, 30% of 500 would give you the expected value for the age group of 18 to 35, and 50% of 500 is the value for the category of greater than 35, right. Why are we taking 500 here? Because the sample that we had is of 500 people, that is n is equal to 500. So here we have the final table for calculation, less than 18 years, 18 to 35 years and greater than 35 years, both the values now you have in numbers. So let's quickly follow the steps for the hypothesis testing with the help of the chi-square test. The first is to define the null and the alternative hypothesis, state your alpha, that is your significance level, calculate the degrees of freedom, state the decision rule, calculate the test statistic, state the results and conclusion. So let's quickly see them one by one. So the defining of the null hypothesis and the alternative hypothesis. For our example, the HO or the null hypothesis would be the data meets the expected distribution. So that means the proportions are equal and there is no difference between the observed and the expected. And the alternative hypothesis for this example would be that data does not meet the expected distribution. That means the proportions are different of the observed and the expected values. Second step, state alpha. Alpha we have taken as 0.05. Next is to decide the degrees of freedom, right. So how do we decide the degrees of freedom? Now these degree of freedom and alpha, these are the two things which we will require in order to read the table value for stating our decision rule, right. So alpha we have taken at 0.05 and degrees of freedom would be calculated as df is equal to k minus 1. Now what is this k? This k is the number of categories that we have divided our data into. In this particular example we have three categories. First one is the age group of less than 18, next is from 18 to 35 and next is like people who are over 35 years of age. So three categories, so your degrees of freedom would be 2 here. Next is to state the decision rule. Now on your screen as of now is the chi-square table. Now there are two things I mentioned that we need to have for reading the table value for the chi-square. So we have taken alpha is equal to 0.05 and for 2 degrees of freedom. So let us see that where does this intersect. So the chi-square table value that we need for this particular hypothesis is 5.99. Now stating the decision rule, for chi-square, if the chi-square value is greater than the table value, we are in a position to reject the null hypothesis, right. So in this case, the table value that we have calculated is 5.99. So our next step is to calculate the test statistic, that is the chi-square statistics, and compare it with the table value. Now if the chi-square is greater than the value of 5.99, we are in a position to reject the null hypothesis. So here is the calculation. Formula being used is summation of observed minus expected whole square divided by the expected frequency. So the value here is 121 minus 100, square it up, divided by 100, 288 minus 150, square it up, divided by 150. Next is 91 minus 250 and whole square divided by 250. So here you may be seeing that we would get a negative value, but when you square it up, it becomes positive. So after the calculation, we have the chi-square value as 232.494. So here I am stating the result for this hypothesis testing. If chi-square is greater than 5.99, reject the null hypothesis. Clearly our value of chi-square is definitely greater than the value of the table, that is 5.99. So we are in a position to reject the null hypothesis. So therefore, what is the conclusion of this entire hypothesis testing with the help of chi-square test? Age distribution of the 2010 population is certainly different from those expected based on the data from 2000 census. That means there is a difference in the proportions and the proportions are not same. Certain times in certain calculations, you might also see the calculation as with respect to the p-value, that is the probability value. Majorly when you calculate this chi-square test in statistical softwares like Excel, you would not get the direct chi-square value, but you will get the p-value. So in that case, how do we do it? in that case, you have to compare the probability value with the alpha that you have taken, significance level. So, if the p-value that you get after the calculation is less than 0.05, let's say you get a p-value of 0.03 or 0.04 or 0.02, then in that case, we reject the null hypothesis and state that there is a difference between the proportions of the observed values and the expected values. So, chi-square test again is a powerful statistical tool that helps in determining the association between the two categorical variables, and of course, it is very widely used non-parametric test in research. Stay tuned with us for more on research methodology. Thank you.